All right, so in this video, what we're going to do is now we're going to try to look at a couple of examples using our mass and volume percentages, mostly focusing in this case on our, excuse me, our mass percents. And so here I'm going to do an example where I'm looking at what is the mass of sucrose, so, a form of sugar. So the question we're asking ourselves is what is the mass of sucrose? Mass, I'm just going to put of sugar in grams. In a typical soft drink, we know that the volume of solution is 355 milliliters, and that has a 11.5% mass over mass concentration of sucrose. And we can assume a density equal to 1.04 grams per mil. In this case, we don't have to do any conversion because everything starts in mils here. And so in this case, I'm given a percent by mass. So I'm given this thing right here. I'm given this mass of solution, or I have a way to calculate mass of solution. This is the question I'm asking myself. What is my mass of solute? And so the way I'm going to figure that out, I'm going to highlight what I'm looking for, mass of solute, is I'm going to, manipulate that equation to solve for mass of solute. And I could just say that mass of solute must just be equal to the percent by mass. So I'm just going to say percent m over m multiplied by the mass of solution. Just manipulating that algebraically. And so I have that mass percent right here. And so now I just have to figure out what is the mass of solution. And I can get that mass of solution is just going to be equal to the volume of solution, 355 milliliters of solution. I'm going to multiply that by the density of 1.04 grams per milliliter of solution. And this will give me, this is our mass of solution. This will give me a mass, in this case, of 369.2 grams of Solin. So what I can do then is I'm going to take that. I now have a mass of solution. I have also my mass percent. So I'm going to take that 369.2 grams of solution, multiply that by my percent by mass. So that's 11.5%, which we can also say is 11.5 grams of sucrose or sugar per 100 grams of solution. Remembering that when I solved for that mass of solute, I also have to incorporate this 100 right here because it's a percentage. And when I do that, I can cancel out grams of solution in the numerator and the denominator. And I get that our mass of sucrose, which I'll do in blue here, is going to be 42.5 grams sucrose, which is just that 369.2 divided by 100 times 11.5. And if we think about if this makes logical sense, that's a little bit more than 10% of the mass. And so, 42.5 seems pretty reasonable. So now what I'd like you to do, and I forgot that these two things were going to pop up, but the first thing I did is I converted from volume to mass of solution using density. And then the second thing is I calculated mass of sucrose in mass of solution using mass percent. And so if we do the same thing here with a question that I'm going to pose to you all, where you're going to pause the video, we're looking for what volume now, instead of what mass, what volume of soft drink, excuse me, do we need that is 10%, 10.5% sucrose by mass? Sorry, let me rephrase that. What volume in milliliters of a soft drink that is 10.5% sucrose by mass contains 78.5 grams of sucrose? We have that same density of 1.04 grams per mil, but in this case, now we're looking for a volume. And so I've kind of laid out the kind of step-by-step process you can do to solve this problem, converting your mass of solute to mass of solution using mass percent, and then looking for volume using density. And so I'll let you pause the video here, solve this, and then we'll come back and solve it together. All right, I assume that you have spent some time looking through this, and so we'll solve this together. So if we follow that first step, which says that we can convert mass of solute to mass of solution using mass percent, we know that our mass of solute is equal to that mass of sucrose, 78.5 grams. And we know that our mass percent is equal to 10.5%. And so we can say that we'd have 78.5 grams solute. And in this case, because the mass percent is given as, an equivalent way is to say 10.5 grams of solute per 100 grams of solution. Now we already have grams of solute in the numerator, so we'll actually multiply by the inverse of mass percent, or another way to say that is we'll divide by the mass percent. And so I'm going to multiply this by 100 grams of solution per 10.5 grams of solute. We multiply that together, and what we get is that this would give us, 747.6 grams of solution. I put the N for solution twice. And so now that we have our mass of solution right here, we're then going to convert that into volume using density. And we know that in this case, let me switch my pen color, we know that our density is equal to 1.04 grams per mil. I have 747.6 grams of solution. And so in this case, if I were to have multiplied by density, I'd have grams squared per milliliter, which is not the unit we're looking for. We're looking for milliliters as our final answer, so we'll divide by density, or another way to say that is we'll multiply by the inverse, and that just says that 1 milliliter of our solution has 1.04 grams of whatever we're interested in, and I'll put of solution. We'll cancel those out as we have done before using our unit analysis. And what we end up with here is that we'd have 719 milliliters of solution. So just solving that, and a lot of this is all about that unit analysis. So recognizing, what the definition of mass percent is in terms of grams of solute per, in this case, 100 grams of solution, and then flipping that around to give us the correct type of output. And so in this next video, what we're going to do is then look at going through and doing our final type of concentration unit. And then with that, we'll do one final set of questions, and then we'll be done.